I'll ask all of our speakers to sit up here, and we are going to do the last part as a panel format. However, I want to open the questions directly to the audience at this point, and I hope you found some stimulating information in these talks. So please step up to the mic. Wake them up. Sing and dance. Okay, I'll start off by giving Niklas a hard time. So we heard about AAI. What I'm hearing is AI. So there's a bit of a clash here in terminology. How are we going to link, if I may just subvert your whole talk, how are we going to link the information that's contained in ELIXIR to the modern machine learning technology, artificial intelligence that's doing such amazing things for other parts of the economic sectors?
So I think there are, is this working? Yeah. So I think there are two parts of the answer, David. So the first is with my ELIXIR director hat on, where I would say that the AI part, I think, is research. And as a research infrastructure, our job is to help people to do that. And so we want to make the data accessible, but actually what we want to do is to make sure that researchers can access the data in various clouds and start to do those interesting science, whether it's AI or whether it's classical cancer genomics, as Jan showed.
Right.
But I think the second part of that, I mean, this is driven by access to large and often heterogeneous data sets. And I think that the big challenge, and Ewan pointed to that this morning, is how will we enable people to deploy computational workflows in clouds in various geographical locations under various regulatory regimens, so you can actually start to do these things. And that, I think, is the big infrastructure challenge that we need to meet.
Absolutely. Beacon is a great start, but you can't do AI over a beacon. So you really need the second phase, and I'm really glad to hear you're working hard on that.
Yeah, so if I may, I think that's, I think there is some method in the madness here, but I mean, clearly interoperability and that deep integration that you're talking about and what we would like to do, it will only happen as a consequence of people finding data and wanting to access that data and then building collaborations around that data so that you start to implement more deeper standards in those data sets. And so I think the beacons and other discovery services, Matchmaker Exchange was talked about this morning, is a great example. I think they have a really important place in this landscape. You can't do any of the deeper integration unless you have scientific drivers, and those are driven by interest and the ability to find relevant data sets to collaborate around.
Other comments? Jan, you want to say something about AI, machine learning, how you view the potential now that you've created this extraordinary data set with the PCOG project? Can we go further?
Yeah, I think we can. AI is very interesting. It's for me, it's still relatively new. I have to admit. I find it very interesting thinking about all the different layers of omics that we're trying to integrate and the interdependencies if we want to understand causalities. And for instance, talking about germline possibly causing a mutational process, I'm sure there'll be other factors influencing what's happening down the road, and I'd be very interested to see what AI can help us to disentangle what's actually going on in a cell from interrelating these layers of omics.
Excellent. We have a question from the audience.
Yeah, I was wondering, you know, with the necessity of having these federated clouds where you can go to one cloud or the other cloud, typically what you'll want to do is some sort of cluster analysis. When you have to have a separate presence in N clouds, how do you think you can overcome that problem of trying to do a cluster analysis across all that data?
That's an excellent point, and I would not say that we've solved that, so that this was not one of the problems that we tried to solve from the start, because the way that we dealt with these multiple clouds is we realized that the output of the cloud's processing was initially a variant call set that we then had to move to one site that everybody agreed would be fair to use for sharing, and we actually had a site that the NIH opened for that, a Jamboree site where we could put all the data for sharing. Later we found other mechanisms using trusted sites to share the outputs. So the problem of clustering omics data that is present on different clouds has not been imminent for us. But I think it will be imminent for the future, so I do have some ideas of about one could do about how one could do this. I'm not sure how advanced they are compared to what others are thinking. I think this is going to be very important to be able to cluster data and use partial results to partial p-values, for instance, to come up with a global p-value and perform such computations on federated clouds.
Thank you.
Another question?
Yeah, so at some point, clearly you will have to make machine learning over distributed databases, right? So to achieve this, you have technically essentially two solutions. One would be, at least two. One would be to make use of, to do this, let's say, in a secure way. You'll have to either make use of trusted hardware, so you bring the data in an, let's say, encrypted fashion into a secure enclave where the data is processed in clear and the results are sent back in an encrypted fashion. This is one solution. The other solution is to perform the machine learning operations on homomorphically encrypted data, so a purely software solution. And there are pros and cons, and it's complicated, but clearly it's going to be on the way, right? So I'd like to hear what the current status of reflection is on that front and how much progress has been made. And possibly not have Dixie respond first.
There are clearly ways that one can compute on encrypted data without decrypting the data. And the most promising probably is homomorphic encryption, but there are limited use cases that can be used for. But I do think it's a technology that we, GA for GH, we need to follow it very carefully. And I think of the, as you know, there's also multi-party computation techniques that are coming down the pike, but that's probably less relevant to this problem than the homomorphic encryption.
Yeah, but you already knew your opinion, Dixie. I'd be happy to hear what is happening on the front of ELIXIR and also Jan Korbel's opinion on this.
Yeah, so again, from our perspective, that is in the research realm, so that would be outside the remit of ELIXIR. Our remit would be to support people to do those sort of projects. And I think it's clear, as Dixie pointed out, and I know this from my own background, the fact that we will have to operate in a federated environment where we want to minimize data transfer, both for the logistical reason of and the cost of shuffling large data sets around, but also because we may not be able to do that. And we will have to access and do partial computation in many different locations. I think that will foster rethink of how we approach problems algorithmically. I think it's clear that many of the things that we do today won't be possible to do tomorrow. But you can often find equivalent results using new algorithms. So, but from our perspective in ELIXIR, that's a research problem. We are partnering with a number of research communities to help them to get access to the infrastructure, but we would not get involved in that. That's, as a research infrastructure, that's a research grant. So I think the partnership will have to be trying to understand what are the requirements on infrastructure to be able to support those sort of research questions.
Right, but the research community in computer science consider that this is not a research question anymore. There are tools that are operational and that would actually respond to your needs. So the things exist and can be used nowadays.
So that's absolutely correct. I think the question is there a biological research question with these tools that have been developed in computer science are being applied? I think that was what Francis pointed out earlier today. It's not about doing new computer science, it's about having the match of computer science with interesting biological questions and then supporting research communities to do these things.
Yes.
Perhaps Jan is better placed to answer this.
I could in principle be. So far our objective has been to reuse what basically the genomics community has developed and make it interoperable. So the algorithmic improvements, we have not really gotten there yet. This has not been the remit of PCOG. I think it should be the remit of future studies, and I'd be welcome to work closely with computer scientists on that. Also, yeah, we do have positions in the labs. If computer scientists are in the audience, they're welcome to talk to us. I think these are very interesting questions for the future.
Okay. Thanks.
I'll just add that, as Ewan explained this morning, we do plan to move the compute to the data, and the primary model is that the person would be authorized total access to the data, but there are levels of authorization, and for very broad use, it would be nice if when the compute came to the data, there was a homomorphically encrypted version of the data that you could offer to pretty much anybody instead of having to go through the vetting process. And so I think we should start planning now for essentially two versions of the data, one that is very access controlled and another one that is merely homomorphically encrypted, which may be a little more awkward to use, but is more widely usable.
I'd like to add that I think the first step toward adding security to what we do today is federation. Because right now we're propagating these copies of data all over the world, which is a huge privacy risk. Absolutely. So if we're able to do federated query, that will add dramatic protection to the privacy of individuals as well as the security of the data for that matter.
Excellent. Excellent question. I wanted to continue with Jan. How do you see the process of translating the wonderful work that was done in PCOG towards actual cancer discoveries and ultimately cancer treatment?
Yes, we clearly need more and better clinical data. We clearly want to involve clinicians more than at this initial phase, which is probably fair enough to say was more driven by technical people that understand the genomics. We did have clinicians in the consortium, but they, since the technical developments and being able to deal with these data on the clouds were, I guess, the primary challenge initially, we didn't have as many as we would love to have. So I strongly believe in a PCOG 2, we would want to have clinical data and clinicians being very closely integrated into what we're doing. So and having essentially all these pipelines Dockerized and all the processes easily flowable or easily portable from one system to the other is the first step to that.
Fantastic. So let's bring this session to a close. I want to thank my speakers again. We have a bright future ahead, and the technology that you are actually producing will make an enormous difference. Let's thank our speakers one more time.